Hello everyone, this is Jenny.
And Chrissy Kim.
We are going to talk about 2012 AP Calculus AB free response questions. The question reads, the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0 when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at time t days after it is first weighed, then dB dt equals this equation. By looking at this equation, we can assume that 100 refers to the adult weight. Let y equals b of t be the solution to the differential equation above with initial condition b of 0 equals 20. So this again refers back to the fact that when the bird is first weighed, its weight is 20 grams. Sub-question A reads, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. Because we're talking about the rate at which the bird is gaining the weight, faster refers to the rate, we understand that we need to use the differential equation in order to come up with dB dt when b equals 40. We can find this by simply plugging 40 into the equation above. So 1/5 times 100 minus 40 is equal to 60 over 5, which is equal to 12. So the rate at which the bird is gaining weight when it is 40 grams is 12 grams per day. And it needs to be in this unit because it is a rate. And since t is in days, we need to write per day here. For dB dt, when b equals 70, we again plug it in to b in the equation above. It's 1/5 times 100 minus 70, which is 30 over 5, which is equal to 6 grams per day. So we can safely conclude that the bird is gaining weight faster when it weighs 40 grams because the rate at which it is gaining weight is much higher when it weighs 40 grams. Question B reads, find the double derivative of b in terms of t in terms of b. Use the double derivative of b to explain why the graph of b cannot resemble the following graph, and the graph is shown here. So in order to find the double derivative of b, we know that we have to derive this equation again. So we derive both sides, and since the constant can come out like this, we know that we will be deriving 100 minus b, which is in parentheses. And the 100 is derived as 0, and negative b becomes negative dB dt because a rule called
chain rule
is applied. So we can simplify this as negative 1/5 times dB dt. Because dB dt is as defined above, we can again plug that into the place of dB dt, and we get this, which is again essentially equal to negative 1 over 25 times 100 minus b. Now if we look at the graph given here, we know that the x-axis refers to time in days, which is t, and the y-axis refers to weight in grams, which is b. So for this period of time, the bird goes from weighing 20 grams to 100 grams. So in short, b goes from being 20 to almost 100. And we know that when b goes from 20 to 100, by plugging it into the double derivative equation, this whole equation will never be positive. This is because when we plug in 100, it becomes 0. And when we plug in 20, it becomes 80 over 25 with a negative sign, so it is a negative. And for all numbers that lie between 20 and 100, it is going to be negative. So it is always non-positive, so to speak. This means that the graph of b of t will always be concave
down.
Yes, so it is supposed to look like this, or it is supposed to have parts of this graph, but the real graph that is given here has parts of concave up area, which does not make sense. This is why the graph here, given here, cannot describe the equation b of t. Question C reads, use separation of variables to find y equals b of t, the particular solution to the differential equation with initial condition b of 0 equals 20. So we again work with the original dB dt differential equation that we had been given, which is 1/5 times 100 minus b. And we know that in order to separate these variables out, we can divide both sides by 100 minus b and multiply both sides by dt. So we get this. Now we can put integral signs to both sides to anti-derive it. And by doing so, we know that another chain rule is being applied here. And then we also have a constant here because, again, we are anti-deriving this constant, and we get another constant here. And the negative sign exists, again, because of the chain rule. And now we can multiply the negative sign to both sides. And because ln has e as its base, we can rewrite this as this. But we understand that by looking at the graph, b is never going to go off of this range. The range is 20 to 100. So by looking at this, we understand that this part can safely come out as a positive. Now, it is time for us to plug in the initial condition and make use of it. The initial condition is b of 0 equals 20, which means that this whole differential equation that we had and that has come down to this, we can plug in 0, 20 into this equation to come up with what c is. So when we plug it in, we have e to the negative c equals 100 minus 20, which is 80. Now we can put ln to both sides, and it comes out as negative c equals ln 80. In short, c is equal to negative ln 80. Now we plug c back into the equation that we had here, and we get e to the negative 1/5 of t plus ln 80 equals 100 minus b. Because this plus sign refers to the multiplication of the exponential parts in the form of this, we can rewrite this as the constant 80. And so the equation becomes this. And by switching the places of the variables here in order to write it in terms of b of t, we get 100 minus 80 times e to the negative t over 5. And this is when t is equal to 0 or larger than 0, since t refers to days.
Question 6 reads, for t in the closed interval 0 to 12, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals cosine pi over 6t. The particle is at position x equals negative 2 at time t equals 0. A. For t in the closed interval 0 to 12, when is the particle moving to the left? So when the particle moves to the left, the velocity would equal
Negative number.
yes. So the velocity, which has the equation of should be smaller than 0. So if we draw a graph of cosine pi over 6t, then it would look like this. And we have to use this to find the period.
And b refers to the constant right in front of t, the coefficient, which is pi over 6 in this case.
The period would be 12.
We're trying to graph this in order to find where v of t equals 0. And we find out that v of t equals 0 when t is equal to 3 or 9.
So the graph is below the x-axis in this interval.
In short, the velocity is negative when t is larger than 3 and smaller than 9.
Now the question B reads, write but do not evaluate an integral expression that gives the total distance traveled by the particle from time t equals 6, 0 to time t equals 6. So what we're trying to find here is the total distance, not the displacement. And the total distance would, of course, be a positive number. That would mean that the expression using the integral would need to have the absolute value sign in it. Question C, find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at time t equals 4? Explain your reasoning. The acceleration of the particle is the derivative of the velocity, which can be expressed this way, and this would equal to the acceleration of the particle. The derivative of the cosine would equal sine and
Negative sign.
And chain rule, which gives us pi over 6. Now, if we want to find out whether the speed of the particle is increasing or decreasing or neither, we would have to consider both of the signs of v of t and a of t. If we consider the sign of a of t first, which would be this, at t equals 4, we would have to substitute 4 for t, and that would give us and this will become this, if we change it into
Degrees.
the degrees, would equal 120 degrees, and when the degrees equals 120, then it would be in the quadrant, the second quadrant, which would have sine as the positive value. So since the equation has sine in it, it would have a positive value for this part, but a negative value since there is a minus pi over 6 in front of the equation. Thus, the equation would have a value that is smaller than 0. Now, if we consider the value
Of the velocity.
Yes, of the velocity at time 4, according to the equation given above, this would have a value of cosine 2 pi over 3, which would be negative 1 over 2. And as you can see, both v of t and a of t has negative signs. Both have the same sign, thus the speed would be increasing. D reads, find the position of the particle at time t equals 4. So what we're trying to find is the position of the particle when t equals 4, which would be including -2, since we have the initial condition of x equals -2, the position of the particle when the time equals 0.
This case, because the velocity goes both ways, both positive and negative, this part is referred to as displacement. And since s is a dummy variable, we don't have to regard s into our calculation.
When we antiderive it, it would become this.
And chain rule is used here.
Which would yield 6/pi. We have to substitute 4 for s and 0 for s, and we have to subtract the value of sine pi/6 multiplied by 0 from sine pi/6 multiplied by 4. The value of sine 2pi/3 minus sine of 0 would equal √3/2, and we have to multiply 6/pi, which will give us the value of -2 plus 3√3/pi.